We drill down to what is tactical domain-driven design. This is the aspects of domain-driven design that take over when we're designing and implementing a service. So this is what's controlling us when we're actually designing and writing the code and producing the software. And the focus on tactical domain-driven design is to build what is called a domain model and to express that model in code. Why to use this is really what we're doing is we're breaking our problem space down to its base case. If anyone here has gone through your traditional computer science undergrad or graduate program, when you take your algorithms course, you talk about breaking down these problems into their base case and then building solutions on top of that. And in many aspects, that's what domain-driven design is doing, right? So we remove these mazes of one-off special cases and patches and these things that muddy our code. And we avoid creating duplicate endpoints that have small little variations between. And we do this by using this domain model, which is also going to bring everyone together, because the model is going to express the language and the processes from all aspects of the business, product, marketing, etc. So they're all talking about the same thing and viewing the same process in the same way. And lastly, while we're kind of on this meta discussion, who is using domain-driven design? It turns out a lot of major companies. I'm not going to spend too much time on this slide, but you should recognize many, if not all, companies here. All these companies are using domain-driven design, at least in one area of their software. So now we can start talking about the meat of this presentation on how to apply tactical domain-driven design. So high-level view, what we're going to do is we're going to encapsulate the business logic in the domain, leave the external touch points, the APIs or adapters, lean. This is lean in the lens of business logic. Some of these APIs, some of these adapters can grow to be pretty bulky themselves, but that's not where the interesting things are happening. All the interesting things are happening in the domain itself, right? These are just transforming and helping us in that aspect. And we're going to create a domain that has the right aggregates with the right entities and the right services. Both of these terms, because we're going to be visiting them shortly. And I will give the warning that a lot of the things we want to cover reference each other. So it can be hard to grasp your mind around it at first, as since they reference each other, you kind of need to iterate over them a couple of times to see how they all fit together. As I said previously, we're going to ensure the domain expressing the language and processes the business experts are using and talking about. So when our entities and our objects in our code and the methods that are using them match the language that the product that the business users are talking about, we're on the same page, and we remove these implicit requirements, implicit understandings, because everything is explicit and everyone's on the same page and thinking about the same things with the same language. Right? Make these important bits explicit, and we ensure the business logic follows don't repeat yourself principles within the domain. So when something has to be done, it's explicitly called out in some service or strategy or as part of an entity, and that happens there. It doesn't happen, in 2 or 3, 4 or 5 different places that if you need to make a change, you have to go around and change them all. No, it's one thing happening in one spot that's expressing the business need and the business requirement. When we look at how an application is architected and structured within a traditional domain-driven design approach, right? You talk about the traditional 3-tiered architecture. Here we have some API layer that's taking requests. We have a big, meaty domain layer, which has all the business logic and is where the magic happens. And then there's an infrastructure layer that's really only dealing with how our application talks to external services, be it other microservices in our platform, other platforms that we're contracted with, or data stores, right? That infrastructure's responsibility is to just facilitate that communication. And we're going to approach this from model first development. So whenever possible, we're going to start with this domain. We're going to ignore the API and the DBA layer. And once we figure out the domain, we can smartly expose the functionality and fill out the non-domain layers. Another way to put this is we're going to do this domain first, and we're going to allow the domain to influence the API and influence the infrastructure layers. But we're not going to take the reverse and allow the API and the infrastructure layer to influence the domain. So I know your heads are spinning, but we can finally start talking about how to build a domain model. And the first question should be, what is this thing and what isn't it? And the answer to that is we have a model along with its services. So here's a high-level view of the OMS's rewrite domain. Left out some of the services, some of the strategies, as it'd be just too many to fit on one side. We can see that we have a model consisting of an order, some of its child objects, a channel with its child objects, and the cancel specification with its child object. And then we have a whole host of services and strategies. They're going to dictate how these things are used and how they influence each other. This is the domain. This is what we're trying to express. And this is where we kind of start creating the shared language and start filling out the logic. We want to drill down into this domain layer, the different types. We really can split this into two. We kind of have the aggregate side, the left side here, the aggregate roots, the entities, the specifications, the repository interfaces, and the factories. And then on the right side, we have the services and the strategies. So I'm going to go through and talk about these different aspects and what they mean and how they relate to each other, right? But the root of this is that these aggregates are the tree structures we saw in the previous slide, and the services are dictating how they operate. We'll drill into the aggregate side. We have an aggregate root that is the root element of a domain model. We'll see that there will be multiple aggregate roots and go over the rules with them shortly. An entity is an object in your domain. Business logic does not cross aggregate boundaries, goes into that entity. And then specifications are a special kind of entity that's used to drive some aspect of business logic, usually in conjunction with a strategy. And just an important note that aggregate roots and specifications are entities themselves. They're just special kinds that have their own rules around them. We go and take another look at that OMS model, right? We can see that this tree structure on the top, as I said, is our aggregates. You can see there are aggregate boundaries in that if you look at the order in its tree, there's no lines between order and channel, and no lines between order and the cancel specification. And likewise, there's no lines between channel and cancel specification. Those are aggregate boundaries. And within that aggregate boundary is our aggregate, the order aggregate. And that aggregate is concerned with its internal state and has all the business logic related to that state. So the order itself is the aggregate root because that is the root object of that aggregate. We want to continue down this aggregate and entities aspect of the domain. We have the repository interfaces and the factories. So one of the most confusing aspects it takes people a while to kind of wrap their head around is that your repository interface. This is how you're going to retrieve already created entities, most likely from a database. That interface is part of your domain, but the implementation is not. Because how that happens, if you have to query Mongo, if you have to query MySQL, if you have to go to S3 and pull a file, is not important business logic to our domain. But how you do that as and how you locate those objects, what parameters you use are. And factories are another way of encapsulating logic needed to create the entity in the first place, right? We'll go over a bit on factories in a couple slides, but the big point to stress here is that sometimes creating these entities can be complicated, and we can use a factory to encapsulate that logic, call it out, and make it explicit the requirements in the process for creating this entity. With that, we can move over to the services, right? A service is a block of business logic that utilizes two or more aggregates, where strategy is a special kind of service that provides some granular and atomic business need, usually along with a specification. We'll define these more, again, in a little bit, but really what we're talking about, a service becomes a strategy when it's atomic and it either needs some other entity to control exactly what it's trying to do, or there are multiple ways to accomplish something, in which case we have a strategy per implementation path. And then some piece of business logic chooses which of those we use. The case that I will examine would be in the order management system. We have the choice to fulfill order items via logistics, because it's a physical item that needs to be shipped to a user, or through telco, because it's like a plan or an add-on the user needs to be subscribed to. So we can create a logistics fulfillment strategy and a telco fulfillment strategy, and then look at the order items to figure out which one needs to be called with which order items. Now, likewise, when we talk about kind of the billing domain, we might have a prepaid billing strategy and a postpaid billing strategy to dictate how the users bill based on if they're a prepaid customer or a postpaid customer. So those are when these kind of services become strategies. Moving on to how to model, right? First thing I want to stress is the domain model is not the data model, right? How the data is persisted is not the domain. Now, we remember from the previous slide, and we do take a model first approach. We can figure out the domain model and then say, okay, I'm going to make the data model a copy of the domain model. And that is fine and great. There's actually a lot of benefits to doing something like that. But if you already have a data model that you need to build on top of, right, you shouldn't copy the domain on top of that, right? So domain can influence the data model, but the data model should not influence the domain model. So to start on how to actually do this modeling, right, we need to figure out our entities. You know, anything we need to store, retrieve, and operate on are entities in our domain. And we're going to figure these out from talking to the domain experts. Product. What words are they using? What are they talking about operating on? What are the nouns, you know, the people, places, things that are coming up in conversation when they talk about the requirements? We're going to take that and we're going to sort these into kind of aggregates and figure out what the aggregate roots are, right? Or force relationships, and each tree is an aggregate. And the important rule for aggregates is that all persistence on an aggregate happen at the root level, both reads and writes. And parent objects control the access to like children objects. So using here, I can't get an order item without going through the order. I can't get a cancel reason specification without going to the cancel specification. Right? These are the overarching control of my different aggregates. Now, there's naturally going to be some kind of connection between these aggregates. And when that happens, you know, other aggregates can hold what I call a weak reference to another aggregate root. In this case, an order is going to have the name of the channel it belongs to. But the order can't access the channel. Something that's controlling the flow of logic would have to ask the order for the channel name and then use that channel name to figure out what channel that order belonged to. And that's important because though orders are related to channels, they don't belong to channels. That's not an important aspect of the order. Lastly, you want to consider identity when you're thinking about your entities, right? How are these things identified? And ideally, each entity should have one primary key identifier type field, order reference, user ID, something that can be shared across the platform and safely with our end users to identify what we're talking about. Sometimes you might find out that your entities have more than one. Sometimes it's an internal and an external because the external party wants to identify this thing with their own reference, and that's fine. But when we start having more than one, I would really double think and think about why we have these different identifiers, and are we missing something that we're not modeling correctly? There's going to be a lot of that when you talk about technical domain-driven design and modeling of why is this not looking right? What am I missing? And sometimes it is just what it is. I know currently we're talking about the billing service. There's 3 or 4 different identifiers that BRM uses to identify things, to identify the customer. And because of that external requirement, billing service has to accommodate that. And that's a good exception because we're saying that this is just a bunch of identifiers because of constraints outside of my control that I need to deal with. Pointing that out to say there are valid reasons, but you really need to think them through and discuss them. Valid reasons as for why an entity might have more than one identifying field. So here are some rules for how you build your aggregates. First major rule is only one-to-one and one-to-many relationships. The second being that aggregate roots have no parent entity, while non-roots have exactly one. We're saying that no entity can have more than one parent. And lastly, only one-directional relationships, parent to child. So a child object should never know what its parent object is. And why these rules? And the answer is it's encapsulating the data and logic so that all changes in processing is explicit, and we don't have hidden or backdoor changes, right? So we know what the flow of these entities are through a single request, and you can't reverse it. It's unidirectional. When things are unidirectional, they're a lot easier to reason about and a lot easier to model and a lot easier to handle. When we start having these bidirectional relationships and these kind of hidden or backdoor ways to change data, that's when we start falling into kind of the big ball of mud, spaghetti code area where I can change anything, anywhere, from any point in the flow. That makes development and talking about the software much harder, slows us down, and reduces our time to market and leads to production incidents. Few more rules is transactions should span only one aggregate. By transaction here, I'm talking about a API call, not the database concept there, right? You'll probably have to read multiple aggregates. That's a fairly typical use case, is that we have some transactional object in one aggregate, and we have a specification in another aggregate, and that specification is controlling how the transactional object's processed. That's typical, probably be your base case for most of your flows. The important piece to point out is that in that case, only the transactional object's actually being written to. And this is one of those rules that is okay to relax, but exceptions should be exceptional. And there should be a major valid reason why you're not doing this. Why your transaction is updating multiple aggregates. And if you find your domain frequently has to update multiple aggregates, that probably means you're missing something in your model, right? So I'm going to use this term model smell very often, pulled it from the term code smell. And that's saying that something's not right here, something stinks. And we need to see if something's gone bad or if something's just the way it is, right? I need to see if the food in my refrigerator went bad or someone bought durian. That's what a smell means. We need to investigate and figure out why. Another rule, entities can only reference other aggregate roots using weak references. This is I talked about on a previous slide. I actually put some screenshots of the OMS code here. So here we can see that the orders aggregate on the left holds the name of the channel, but you can't access the channel directly. This is again to really isolate what is being updated. Parents can only control the access to their children, right? This goes to the unidirectional flow. Parent entities controlling access to their children mean that at any point in code, I know what I can and cannot reference, what I can and cannot access. That said, it's okay for a parent object to go and give one of its child objects away as a return value. Right? If I have some customer object in a payment service, and the customer object has a wallet containing their different cards, I can ask the customer object, say, hey, give me the preferred payment method, the preferred card, and get a card object back, and then pass that through whatever services I want. Right? In that case, the parent is controlling access to that card because I can only get that card through the customer object. When you combine this with the only unidirectional relationships, that means at any point in an execution, I can't go to the card and say, hey, who's your owner? What customer do you belong to? Right? So I know that if I'm in a method that's only getting this card as a parameter, I have no way of modifying that customer object. So that's going to simplify my code. Quick recap, the last 7 slides, right? When you're building these aggregate roots and you're building the entities and the aggregates in your domain model, right? You want to focus on making sure you only have one-to-one and one-to-many relationships, right? That aggregate roots only have no parent entity, and non-root entities have exactly one. Only unidirectional relationships. Transactions should not cross aggregate boundaries, so write to one, read many, write to one. Entities only reference other aggregate roots using weak reference. So that is another important concept that wasn't stressed properly previously, that when an entity needs to reference something in another aggregate, it should only reference the root of that aggregate, not a child element. If you have to reference a child element, that means you have a model smell, you need to investigate why. Child entities cannot exist without their parent entity. That's a byproduct of this aggregate root and only unidirectional relationships. And lastly, parent entities controlling access to their child entities. So with that, we can look at our factories and repositories. Right? Factories and repositories are how we're going to control basically persistence and creation of our entities. Factories are simple. They're how we create our aggregates and entities. Usually, constructor is enough for this. If you're using a language that has a constructor feature, you don't need to go creating a factory for your simple entities. Though sometimes, if your entities are very big and bulky, it can be useful to make your code cleaner and more easily readable and more expressible by creating a factory just to take that block of logic and put it in a explicit place. Hearing some yes, Nika?
Yeah, a couple of one question and one comment. So from the previous slide, you mentioned aggregates. If you can go back to the previous slide, sorry.
Yeah, no problem. This one?
So only one-to-one, one-to-many, and no many-to-many as well, right? That's something we have to avoid, correct?
Yes, many-to-many is definitely something we should never have.
Yeah, so you haven't mentioned it here. Any reason you haven't explicitly mentioned it here, or is it because it's obvious?
Yeah, I made the mistake of assuming that that would be interpreted as that as well. So I can update the slide deck for that.
Yeah, no worries, no worries. Because I remember when I first started, following DDD, that not having many-to-many was something I didn't realize the value immediately. I felt I used many-to-many before, so the fact that many-to-many can be replaced by a directional one-to-many, right? So that's important point, I think. The second one is more just a comment that the factories, you don't need to overthink the factories too much, but basically, as Pete mentioned, the constructor provided by most languages is enough for 90% of the scenarios. But when you do need something more to aggregate all the entities you need, one thing you can use is if you use Spring, it comes out of the box. There are factories that are provided out of the box, which exactly is the implementation of this pattern. So if some of the guys who who are strong on Spring, is just for your reference, that these basically already done by Spring, so that's why you might not explicitly know it, but it's actually handling this scenario. In other languages, you'll have to implement the factory pattern by hand. Makes sense, Pete? Am I saying something wrong because it's been a while?
Yeah, you are 100% right. I do want to piggyback on the many-to-many aspect as well. That typically, when you have a many-to-many relationship and you're looking at that, that relationship itself is an entity that was really controlling something. So if you think that I have many students in many classes, and it's a many-to-many because each student has enrolled in multiple classes, and each class has multiple students enrolled, that student enrollment is most likely its own entity that you want to express in the model. Things like that. All right. So moving on to repositories. So this is your CRUD operations on aggregates, and they must only exist for the aggregate roots. You shouldn't have a repository for non-root objects, and they should only return aggregate root or a collection of the aggregate, a list or an array or a set. The interface is part of your domain, but the implementation is not. Because MySQL versus Oracle versus Mongo isn't important to your domain. And you should only have one method for insert and update. Depending on your language and your framework choices, sometimes these might be the same method. And you must have it, you should have max one method for a delete operation. But I would say avoid delete operations if at all possible, and favor soft deletes. I favor setting some is enabled flag to false or is deleted flag to true, and keeping that in the database. And your all retrieve methods should be in the format of like find by X or retrieve by X. The example I'm using is find by customer ID, find by customer ID and status. That should be the format of your methods. Because the fact that I can locate these things by my customer ID or my customer ID and a status or a date range are important things to express in the domain. So this kind of ends the rules on our aggregates, but I do want to talk about some anti-patterns that we see often. Right? And the first anti-pattern is kind of this idea of a God retrieve method, in which case we create some query object, which is passed to the repository to find things. So whenever I need to find an object, an entity, an aggregate, I create some other object and I pass it to the repository. Right? This muddies the code because now every caller has to create this object. And this creation of the object can be lengthy and unclear and takes the flow of the code away from accomplishing the business logic into performing some boilerplate things to query. Now, this said, there are important use cases, usually around admin use cases, where when we get this call, we don't know when we get this call what the constraints we're going to ask the database for to retrieve the objects are. If I want to find all orders between this date range and this status, if I want to view all payment transactions from that went to Stripe and failed, right? Typically, these come into one API call, and then I have to figure out which parameters were included and find the right query. So it's okay to create kind of a specification to pass to the database to serve these use cases. But we should really think this out and only use it when it makes the code more clean, and only use it when the parameters in that flow are not known when that method is called. And lastly, do not stringly type these things. What I mean that is, don't create these objects where you say, where you introduce the field that you're constraining as a string. If I have a bunch of parameters that I can fill out for an admin use case, each of those parameters should match a field in that repository specification, so that looking at this thing, it's clear what I'm doing with it. The next is the update X, add X method, where the repository itself has methods to dictate which fields are being updated and if elements are being added or removed to the entity, right? So at this point, when you do this, the entity itself is not controlling its data. The repository is controlling its data. So when that happens, you're broken this idea of encapsulation that domain-driven design brings. In doing so, you're really coupling the persistent state with the application state. Next is multiple patterns through the data model, right? You'll come into areas where you have an entity that might be expressed in multiple models. But when this happens, sorry, multiple aggregates. When this happens, you need to be careful that you're not sharing an instance of that entity to multiple parents, right? For an example, in the order management system, right, we have a price entity that belongs to the order and belongs to the order items and belongs to the product, right? It's the same, kind of contains the same business logic, so it might be the same object in code, but the way it links to each other, we need to ensure that when it comes time for persistence, that the same row in the database isn't mapped to multiple parents. Because when that happens, we introduce these backdoor updates. And DVD is all about making this logic in code explicit. The last anti-pattern I want to talk about at this moment is this data model pretending to be a domain, right? This is, again, making sure that we just don't take a data model and say that's our domain model. When we do that, we're creating a lot of headaches for ourselves, because our data, as it's persisted, should be able to be in the form that makes persistence the easiest and persistence the best. But our domain model needs to be in the form that makes our business logic the clearest and most expressible. And sometimes those are not going to match up. And they need to be able to evolve independently. So I know this has been a lot. This is probably about 3/4 of the things to cover. So a lot at first. I just want to do a checkpoint so we can reference what we just talked about, right? There are aggregates, an aggregate root that encapsulates our entities, can retrieve from a repository, and be created with a factory. So with this, we can move on to the services, strategies, and specifications. And this is all about where business logic goes, right? Business logic, wherever possible, should go to the entity that controls it. Right, our order entity should be responsible for generating and reporting its costs. The payment transaction entity should be responsible for reporting if the payment was successful or not. But what happens when logic can belong to multiple entities? And when that happens, we encapsulate that logic in a service. So our services are for logic that's part of our domain, but either does not belong to an entity or can belong to more than one. And by creating these services, we explicitly make it a part of our domain. This is usually needed when two or more aggregates interact, or when the business flow at that moment needs to make a call to an external system. Our specifications are a type of entity that really dictates how and what kind of logic should be applied. Some abstract cases are a notification preference specification might dictate how to notify a customer if they want SMS, if they want email, along with what categories of notification the customer can receive. A login specification might specify how many field logins a user can have before they're logged out, and how many devices they can be logged into simultaneously. Right? In each of these, we can see that these entities, because specifications are entities, is controlling some area of business logic. And the reason I bring this up here is because that leads us into strategies. Strategies are a subset of services that contain a specific atomic piece of business logic, and they usually work in conjunction with specification. In the previous example, the notification preferences, a send notification strategy will look at that specification and say, okay, this customer wants us to send email, I'm going to send them an email. Or this customer wants to get an SMS, I'll send them an SMS. That's what makes that service a strategy. Alternatively, you might have multiple strategies to perform the same piece of business logic. I used a previous example from OMS having a logistics fulfillment strategy and a telco fulfillment strategy to fulfill the order items based on when you be shipped to the customer or subscribed by the telco services. Likewise, another example here is the prepaid billing strategy versus postpaid billing strategy. If the logic to bill the customer is going to differ between prepaid and postpaid, we can create multiple strategies and then look at the customer to figure out which one to use. This is where strategies come into play. With that, there's another set of anti-patterns to talk about. And the first one is the lean domain, which is your domain should not belong as well. It should not just be a bunch of fields with getters and setters, right? There should be logic in those entities, and there should be as much business logic in those entities as possible. This is one of those that said moments, because what we will see is that when you're in a multi-tenant or a single code line platform, you tend to use specifications to dictate what logic to apply, and then strategies to apply that logic. And that pattern does tend to take logic from the entities and move them into strategies. So this is something to keep an eye on and realize that as these domains evolve, and as we add this configurability and flexibility to the platform, we will see a leaner domain than you might see in other platforms. The next anti-pattern is this kind of idea of a one global model. And that's the idea that, since we have a user service, everything about the user has to go in there, which is not the case, right? Your service will have a model for some idea like a user. The other services will have their own model for. And that is really the world we want to be in, because your service is only going to add the elements to its user model that it needs to perform this task. That idea of the notification specification talked about earlier would belong to the user model within, say, a notification service. but does not necessarily need to belong to the user model in the user service, right? And the same idea of like a payment service might be storing payment methods in its user model, but that doesn't mean that OMS or the order management service or the telco services need to store that same data, right? The same concept of a user can exist between multiple services, and that is good and that is wanted. Same time that do want to consider source of truth. For instance, in this user example, does your service need the user's name? Should we be getting that from user service, or should I be populating it myself somehow? Right? Those are the kind of conversations and things we need to think about. Next is the mutable transaction specifications. And what this is saying is that a common use case you're going to come across is that you have some specification that's going to dictate how a transaction object is processed. And it can be an anti-pattern to allow that specification to be updated live. Because then you have to ask your question, what happens to my in-flight transactions? And there are some tricks you can do about making these things, these specifications, immutable, so you can't change them. If you do change them, a new one is created, which will mean that any in-flight transactions are unaffected. Or you create a copy of these under your in-flight transactions. So if you change the specification, the in-flight transactions are not affected. Calling this an anti-pattern might not have been the best call, but it is an important call out to think about how your services and your strategies are using these entities and what happens if they change. Lastly, the last anti-pattern is passing services or repositories to entities is something that you don't want to do, right? When you pass a service to an entity, you allow that entity to start modifying other aggregates. Your service has global access to all the repositories across the entire domain. When you do that, you get rid of the boundaries between aggregates because now aggregates can be updated by others, which destroys encapsulation, right? And when you pass a repository to an entity, you're now blurring the persistence logic with the domain logic, right? Your services are going to run a bunch of logic, call a bunch of entities, combine things, and then say, okay, whatever's changed, save it. And that's what you want. You don't want to be passing these repositories to these entities and then now, later on, have to worry about has this been saved, has this not been saved, has this thing been called, has this thing not been called, right? It's best to only allow repositories to be called by other services and strategies. So when you put this all together, right, we can see that we have expanded our previous aggregate section with the specification of services and strategies. We're going to call that a specification is maybe an entity, maybe a specification. Specifications drive our strategies, which is a special atomic kind of service. And the service mediates business logic between multiple aggregates. This is how everything really fits together. To go back and ask, why are we going to bother with all these rules, right? And this goes back to the first handful of slides where we're expressing this domain, this business domain, this problem space in code, and we're trying to bridge the gap between our domain experts and our software, right? And avoid a bunch of ambiguity. To do this, we need to set these kind of groundwork in this framework in these rules so that we can encapsulate everything and make sure that we'll talk about the same flows. Without these rules, you end up into that big ball of mud kind of application architecture where you really can only know what's going on by following the code from start to finish, right? And analyzing every line. When everything's modeled with these aggregates, these services, and these strategies, you can tell what's going on by just looking at what's talking to what when. And that's what really brings the model all together, bridges the gap, and makes the code expressible. So how are we going to tie this all together and create a domain-driven design microservice in Circles? To start that, I do want to talk about 3 more definitions to make sure we're all on the same page. The first is an anti-corruption layer. This is basically a transformer, right? We have our domain model, and we're talking to and being called by other services that have their own models looking at this data. And what an ACL does is just transform back and forth so that the way other services model their data and present it to us doesn't corrupt the way we model the data and we use it. The second is the DTO, the domain transfer object. This is just the kind of object we're going to use as the entry and exit to the domain. It essentially creates a static API into the domain, so the domain can evolve separately from our API. And lastly is what we've been calling an application service, which is the entry point to the domain. So do not confuse the application service with the domain service. They really are 2 different things, just with a very similar name. And what we're going to see is the application service is kind of the manager for the APIs. To give a better graphical representation, right? It needs to be an API layer with application service fronting the core of the domain. And then in the infra layer, our external service connectors, so when you call another service, are fronted by this anti-corruption layer that's going to prevent those services models from corrupting us. This application layer is going to call one and only one application service method. It's not going to perform any business logic other than null checks, sign checks, make sure this thing's positive, it needs to be positive, that kind of thing. It's very basic. And lastly, it's going to decide how to respond to the caller in an error scenario. Our application service is going to define the transactional boundary for the requests. The transactional boundary here is the database level transaction boundary. So within the application service, whatever changes happen to the domain, it should be all or nothing as far as persistence goes. That said, you might have some use case where you need to save some and not the others. When that happens, it's expressed explicitly in the code that, hey, something bad happened, so that's why this is being persistent and that's not. It performs the course orchestration with the domain, service, and strategies. The big piece to call out is that it is only going to accept an DTO and respond with the DTO. So the domain objects, your entities, are never accessed by the API layer. And likewise, when they're re-accessed by the infra layer. Our domain layer is what we just spent the last 15 minutes or so discussing. So we should know what's in here is our entities, our aggregates, our factories, our repositories. This is where all the business logic is going, right? This is where the magic happens. And lastly, the infra layer is controlling access to the external world from the domain. And this is going to allow the other services to be evolved without corrupting our domain, either because their APIs changed and we now need an API call, the transport method changed, so we need to use a gRPC instead of REST. None of that's interesting to our domain. Now that none of our domain logic cares about that. Or maybe we need to go migrate explicitly from calling one service to another because of some migration, right? That again is not interesting to our domain, so that goes in the infra layer. So our logic stays explicit in the domain. So in closing, a handful of last lines. A couple of things to keep in mind, right? Your domain is not static. It's going to change over time as the business requirements change and we get a better idea of what's needed from the platform. But this is not an excuse to neglect a good first domain model, right? The domain model should evolve over time in small incremental changes. And never ignore the language of domain experts, right? Our product is defining the domain. But the model should match the way they talk about and how the platform operates, right? The nouns they use should be matching our entities. The way they talk about how things interact with each other should match our services and strategies. That is where a lot of the strength of domain-driven design comes from. That is how that gap between product and engineering is bridged. Second to last, logic belongs to the domain. It's not on the UI, it's not on the API, right? If the API layer, UI layer is driving the logic, then something's gone wrong somewhere. And you need to investigate and figure out why. And the last piece is just to stress this for, I think, the third or fourth time. The domain model is not the data model, right? Data model is its own thing in a database somewhere. Our domain model is being created and used to serve the purposes of the business. The data model is being created and used to make sure these things can be persisted given how another piece of software works. It needs to be able to evolve independently. And if you bring the data model into the domain, that means your domain is now dealing with the constraints of your chosen data store, which is not where we want to be in. All right. And that concludes